I think we're live. And we are live. Good, we're working. So, what is it? 3:25. So today what we're talking about is exponential functions and the number e. Okay, so what we did is in our journal we talked about what the number e happens to be. The number e is kind of a weird thing, but it is a number. We saw on our calculator that you can go, and on my calculator, the number, there's this e thing. Actually says e right there, so if I hit second e, there's e. And what is e? It's about 2.71828 blah blah blah. But the way we define e is this. We know that the number e is equal to approximately 1 plus 1 over infinity to the infinity power, okay? And we put in bigger and bigger numbers in our warm-up. We put in 10, 100, 1,000. We even put a million, and it got us closer and closer to this point, 2.718. So the bigger the values for x, the closer we get to e, which is approximately to 2.718, blah, 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 blah. Okay, the number e is important because what it does is it is a base. It's a base that describes continuous growth or decay. Continuous growth or decay. So I want to graph y equals e, and I'm going to put a 1 right here because I think the 1's super important. The 1 isn't visible, but the 1 is super important because when I graph this graph has to go through the point 1. That's my beginning amount, okay? So if I put this in my calculator, and I just go straight to y equals clear, and I go my 1, and I go e, because I got an e to the x button here, e to the x, right? And if I graph, I may have to change my window. Yeah, I'm going to change my window, but that's still not a bad picture of it. I might change my window slightly. No, I might leave it there, okay? So it looks like this. Let me be more specific. One of the things I can do is I just need the shape of it. And it's going to look something like this. We need the shape, okay? So when we graph these, I need a couple of things. One is the shape, the correct shape, and then I also like to put in the asymptote. There's a horizontal asymptote here because it will never reach 0, okay? So it never reaches 0. So far as domain and range, the range is very specific. Now the domain's everything because it's forever wide. All x values, you can plug anything in for you want, but the domain's just simply going to be x equals all real numbers. But the range is more specific. Since there's no negative values down here, right, then the range happens to be simply a y is greater than 0, okay? Never, not equal to, but everything above 0, okay? And that's why I have this horizontal asymptote. It's a boundary line, okay? It's a boundary line. Now, in number 2, we can graph this on our calculator. We can. There's some things I know about it already. Let's just put it on our calculator. We'll go at 3 e to the x, and then I'll go subtract 2. Let's see what it looks like, okay? Graph this one. All right. So what happened in this particular graph is it just took, first of all, my graph and dropped it down 2 spots, right? So I take this graph and go 1, 2. So I know for sure it's got to go through this point right here. So this graph, the whole thing went down 2. And the asymptote had to go down 2 also, right? So the asymptote went down 2. Down at -3. So on this graph, we just took our parent function, we moved it down 2. So take the asymptote, move down 2, puts it here at -2. And then the graph itself is here at -1. Hi, Molly. Did you ever find your wetsuit?
No, I don't know where it is.
I could have sworn we had it.
Person in your class.
Oh, yes, she's registering. You want
Okay.
to put it right there on that desk right there?
Yeah.
Thanks. Okay, domain and range, that's easy. Domain is x equals all real numbers. And the range, well, the asymptote dropped 2, right? The range is here. It never quite touches that. Y is greater than -2, okay? How am I doing, okay? Seem not too bad? And again, we can always use our calculator if we get stuck to graph this, right? Okay, number 3, let's graph. Y equals 2, so for sure I know this, before I even graph this, it's going to go through 2, okay? That's the beginning amount. It has to go through 2. Before I even graph this thing, it's going to go through there. So let me go ahead and see if I can graph this on my calculator. Clear. I'm going to go 2. I'm going to go to my y equals e to the x, which is right there. And I'm going to go to the -0.2 x value, okay? Now let's see what it looks like. Graph. This one's going down, isn't it? So I don't need a perfect shape, but I just need it to look something like our curve like this. Okay, and again, I'm going to put in my horizontal asymptote at y equals 0. And this one's going to be exponential decay. Right? What's the percentage of change? We're going down 20%. So in a sense, you can see the percentage of changes here. The percentage of change is that number there. So the percentage change is this number, which is a -0.20, or it's a -20% as you're losing, okay? So we could rewrite this as y equals 2 times 1 minus 0.20 to the x power, because you're losing 20%. How am I doing, okay? Turn the page. All right. So E is kind of a funny thing, because E is just this funny number, but we can still manipulate E like we would manipulate X's. This is just, okay, ready for easy? Easy, easy. E to the 10th power. You okay with that? It's like E times 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 E, which is E to the 10th. Thumbs up on that? Is that pretty easy? 2 ways to do this one here. I wouldn't do it like this, but if you get a little bit confused, you can go, okay, write it 3 times. Write it 3 times. Now this is a pain, but it shows why we're going to get 27. Do you see where the 27 came from? 3 times 3 times 3, because I wrote this 3e 1, 2, 3 times, and then e to the 15th power, right? Because 5, 5, 5. Now, an easier way is just to know that I've got 3 to the 3rd power, right? You okay with that? And I'm going to multiply exponents. Wouldn't that be easier? 3 to the 3rd power is 27, and then I'm going to multiply exponents, okay? This one's pretty easy, too. I'm just going to divide 12 by 4, and I'm going to get 3. And then 6 of these e's will cancel 6 of these e's, right? 6 of these, because it's e times e times e times e times e. 2, 3, 4, 5. Don't do it like this. Let me be an annoying math teacher. Please don't do it like this. 1, 2, 3, 4, 5, 6, 7, 8. But it really shows cancel, 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 cancel. I think I canceled one too many. There we go. And cancel, and I'd have 1, 2, but then you guys would automatically know 6 of these cancel 6 of these, e to the 2 on the bottom, right? Okay. Banking formulas. So this stuff can be used in banking also. So let me show you an example. So write these formulas down. First of all, compounded interest. we're going to have P of t equals P0 times 1 plus R over N to the NT power. Write that down. And write this formula down. P of t equals P0E to the RT. Okay, write that formula down. These are banking formulas that we're going to use, okay? Everybody has a good calculator. You're going to need a decent calculator to do these problems, okay? That's why I like to share my calculus with you, okay? All right, let's see how this works. Now, before we do anything, T is time in terms of years, right? T is time. T is time in years. P0 is your initial investment, and N is the number of times you compound. N is like quarterly interest, would be 4. Or they compound it semi-annually, which is 2. Or you compound it monthly. So if you can get something compounded monthly, every month they give you a little bit of money. Not much, but then the next month you're making money on the money they gave you. And then the next month you're making money on the money they give you, right? So compounding your money is an awesome thing because you're making money on your interest. Does that make sense? Okay. This one is you're compounding it continuously, which is really great because you're always making money. Okay, so let's go through this. So you guys know Keegan. So Keegan has to invest $4,000, okay? The first bank will give her 4% compounded quarterly interest for 5 years. We want to use that formula because it's compounded quarterly, okay? Compounded quarterly. In the second bank, we'll give her continuous interest. Well, we're going to use that for. So let's do this problem, and let's have Keegan go to the bank and find out how much money she's going to make. So, first of all, let's do the bank 1, our first bank. Bank 1. Bank 1 is quarterly. So we're going to go P of 5. Now I'll slow down for a second. P of 5, because you're going to find the principal after 5 years. Okay, P of 5 is like a question. P of 5 is like, how much are you going to make after 5 years? Is equal to, well, her initial investment is 4,000, so 4,000 goes here. So I'm just following this formula, 4,000 times 1 plus R. R is the interest rate, which is 4%, right? Well, 4% is 0.04 is a decimal, right? Don't mess that up. Everybody agree with that? I know that. So I'm going to go my 1 plus R, which is 0.04 over N. N is 4. Because we're going to compound it quarterly. N is 4 to the, let's see, the power says N, which is 4, and T is 5. Okay, in this case, N is 4, and we're going to leave it in for 5 years. So let's see how much money Keegan's going to make at our first bank. All right, so I'm going to need a calculator. So, okay, 4,000 parentheses 1 plus 0.04 divided by 4, because quarterly, to the power of 20, right? You guys agree with the number 20? Or I can just go 4 times 5, but, you know, same thing. All right, enter. So she made about $880. So her total amount in the bank is going to be about 8,000. Oh, I'm sorry, my bad. $4,880 and about 76 cents. Okay. Now, will she make more money if she compounds it continuously? I hope so. So bank 2 is going to compound her money always, every moment, every second in time, if there is such a thing, right? So bank 2, she should make more money, right? Because it's going to be compounded continuously. So we're going to use this formula. So we're going to go P of 5, because we're going to plug it in for 5 years. It's equal to, okay, our initial investment. P0 is our initial investment, which is our 4,000, times E to the 0.04, because it's my interest rate, times 5. Okay, now, and again, I'm going to put this in my calculator. Let's see what happens. 4,000. And I got my E button in my calculator right down here. E to the 0.04 times 5. And let's see. So she did make more money. Maybe only $5 more, but she did make more money. Now, if she was a billionaire, she'd make more than $5, right? If she's a billionaire, maybe she'd make 5 million, right? Who knows? That's why the billionaires stay billionaires. There's a reason they stay billionaires. They have the money to just plunk around. And the rest of us, well, that's right. We have a good life. Okay, so that's what I have for notes today. And let's take a look at our homework. Our homework's in our journal.